the beginning itself, you need to start, you have to plan. That planning is what is essential. And many of the times we may choose a wrong method and tell that everything is fine, but that is not appropriate. We need to understand the design requirements. It is not the paper which says that I want this NDT method. Why we are using this method? There are certain things which cannot be captured by the NDT methods, like ultrasonic or X-ray or those things. Like physically, once we know the end requirement, we'll be able to do a better job. That competency, that understanding is what actually is required for a better quality input as well as improvisation. So there are many methods, and all methods we can just try to summarize into this one. Like initially there was nothing, and initially we thought there are only 7 colors, but then we know that beyond that we have many other methods also. So there is a material or test object, there are waves, either electromagnetic or mechanical, and they interact with the material or test object, or there is a material interaction with the material or test object. Then together we get the output, and then we interpret, evaluate, and decision make. So this is what is actually NDT process. We can tell in a unified way. It is observation of interaction of waves with the matter, and then the output we are trying to analyze based on our requirement. So these are the different kinds, like a combination of all these things we convert into visual, because our mind is the one which is the interpreter. Other things give information, but the decoding happens in our brain. So there is I'll shortly cover in this one. There is a requirement for developing one optical structure. This is around 1 meter height, and will be around 621 kilometer altitude, and it has to give a 1 meter spatial resolution. Just imagine that one. So, and if you say the deviation is 5 microns for a 10 degree centigrade variation. So if you just compare with the metrology slip gauges, they'll have of the order of 100 microns for this 10 degree centigrade. So how do you control this much? If you don't have a proper control, what can happen is this blurry pictures will come. So for that, multiple process trials initially, NDT, then to say that it is fine. Initial process, it led to some of the defects. So the NDT inputs provided improvisation requirements, and process was fine-tuned to get the no defect process. Then the deviation somehow in some of the parts was attributed to it could deviate, it could be traced back to the material non-conformity. So, and some of the things, it led to material mechanical characterization and then made acceptable. So with all the things, components were realized, and assembly was done, and during vibration test there was some deviation, like there was a reduction in stiffness. So that also the NDT could provide the reason for the variation by assessing the overall assembly, and there was a Dees bond, and that was the size of this Dees bond and location was fed to the FE model, and that FE model could tell that yes, this reduction is possible because of this one, and then it gave a further confidence saying that yes, you go ahead with the testing with some correction, and then it was successfully done, and so it was flown successfully. So that is one case study. Another one was laser shearography for plastic film. So when the plastic film, this is actually sandwich structure. So when it is done with a ultrasonic C-scan method, which provides the transmission of the sound through the thickness. So in the specimen, if you see, there are 5 and 8. Those are the 2 locations it could not detect. So we know that the absence of resin in between the skins as well as plastic film cannot be detected by this method. So it was told that you have to control in the process. But one of the times it was actually missed, and then there was a control coupon which failed at lower level. That was traced back to the plastic film. So how do you give the confidence? That led to another requirement. So now you have to make, you go through the literature and there nothing, actually literature is silent about this. So you, once again specimen was made and we did the thermography system. It could detect actually, but then as you see, yeah, I'll just close it another, how many times? 1 minute, okay. Right. So this is actually a non-portable one. So we had to go through the another method like laser shearography, which could detect the defects, and then we could test the panels and clear for the this one. So this was the so we could clear those things. These are all the input that can be provided for confidence building and the quality assurance. So third portion, how quality improvements are possible. So 5 minutes, how much? 2 minutes. Yeah, 1 minute, fine. So there are, I'll just go through the last three, like what really is required. My thought is actually availability of the standards and training material in local languages. This is going to help us improve lot of quality. We have great people who are not well versed with the English, but they can really understand the local language. Yeah. Second two, I'll just do. Training and certification of operator and inspection personnel. Certification is important. Third one is development of indigenous technologies. Because if we want to really do a good job, we need to promote the right people at the right place and with the right motivation. So Lunar X Prize model can help everyone to achieve their capability. Thank you.
Yeah, now I request Mr. S.P. Joshi to take the podium. Thank you.
Good evening, everybody. So everybody is ready to receive what I am going to speak. This program what NIQR has organized and the topic that are there in the program are really very interesting. Particularly the sustainability in quality is a very interesting topic. And I must thank Shri Murli Shankar, Dr. Swaminathan, Mr. Shriram and P. Kaniyappan to include me for this particular program. Thanks a lot. This sustainability in quality, why I am saying it is very interesting, because we must understand the difference between the traditional quality and the sustainability in quality. When we talk about traditional quality, we always talk about the, say, I am from automobile industry, so I will always speak about the traditional quality is dimensions, the volume, the color of the vehicle, the quality of the painting, the conformance to the design. So these parameters I will be talking. And similarly from other sectors of industries, the products that are coming out, people will talk about the conformance to the design. However, sustainability in quality is much beyond that. I will give some example which will make it very clear. A car manufacturer or a truck manufacturer is putting a vehicle on the road. The vehicle is manufactured, made as per the designs. The design is already tested and it is a proven design. The customer is very happy with the vehicle. The manufacturer is also happy because the customer is happy. However, when the vehicle is moving on the road, if that vehicle is polluting the atmosphere if the vehicle is giving excessive smoke, or if when the vehicle braking is done, if there is a sharp noise that is coming from the brakes, what happens to the society? The people who are there on the road, they have not paid for this vehicle, they are not interested in this vehicle. The customer for that vehicle may be happy because he is driving and he is getting his condition satisfied. However, the people in the society definitely will be saying that why we should bear this particular problem. So, even though the vehicle is manufactured as per the design, as per the conformance, and as per the rules and regulations, the people are not happy. We have to think about the society, we have to think about the environment. And the product which is polluting the environment, or the product which is disturbing the society, is really in the long interest is not good of a good quality. And there the sustainability in quality comes into the picture, that you have to do something more than what is there on the design board. You have to also think that the society is protected, the atmosphere is protected. I will give one very small example here. That is an experience that we have seen. I joined Tata Motors in 1973, and that time the Pune plant was just coming up. There was only one training division and some computer section, that's all. The other plant in Pune, that is the Chinchwad plant, there was a machine tool division and the foundry was just coming up. The foundation for the foundry was going on, and that was the biggest foundry in Asia. This foundry that was there in Pune plant was the biggest foundry in Asia in terms of the furnaces that are installed over there. So when this work was going on, the chairman during those days, Mr. Sumant Mulgaonkar, he used to visit Tata Motors Pune plant on every Saturday and Sunday, because Saturday and Sunday used to be the holidays in Mumbai, so he used to come to Pune plant and then he used to sort out the issues over here. The CEO of the plant used to put before him all the sanctions that are required because the new plant was coming up, and he used to discuss and then he used to settle. When it came to foundry, when the proposals were put for purchasing the furnaces and purchasing the other equipments and machineries, Mr. Mulgaonkar just smiled and said, "Ki, you just tell me that in this foundry, how many trees are you going to plant?" So the people said that we are talking about furnaces and we are talking about foundries because we have to order all these equipments from abroad. Those were the days when you require license for getting the things from outside, and it used to take 2 to 3 months time for getting the equipments from any other country. So people said that okay, the concerned people said that okay, we will plant around 1,000, 2,000 trees. He just smiled and he said, okay, we will see this next time, next Saturday when I will come. And that time our horticulturist in Pune plant was the horticulturist of Vrindavan Garden, Bangalore, Mr. Sharma. So Mr. Sharma was also used to be in this particular meeting. After 2 or 3 meetings, when the things are not getting settled, the chairman used to ask only one question: how many trees are going to plant? Incidentally, let me tell you that there are 250,000 trees in the plant as of today also. So he used to ask, how many trees are you going to plant? Ultimately, people contacted Sharma. He said that they discussed with Sharma, and then they said that okay, we will plant 4,000, 5,000 trees. He said, I want 25,000 trees immediately around the foundry, and later on you must increase this figure. Ultimately, people agreed, the sanctions were given, the work started. When the foundry was inaugurated, when the foundry started, after 1 month, the chairman came with some experts. They measured the temperature within the foundry, and then they measured the temperature around the foundry, beyond that those trees. And they also measured the particulate size within the foundry and outside the foundry. There was a difference of 4 to 5 degrees centigrade outside. And then he said that, look, why I am talking to you, because around our foundry there is a residential area. We are doing our business, but why we should penalize those people for our business, what business we are doing it. And I don't want any particles or any dust to go and get into their house. So that is why I am asking that so many trees are required so that it becomes a filter. This is sustainability in quality. You are doing the business. You are doing the business in a proper way. But at the same time, you have to ensure that the society at large is not disturbed. Now here you can see that the traditional quality, in the traditional quality, we talk about the customer requirements. If you take the example of a mobile phone, anyone will say that, okay, I want a good mobile phone with a good camera. Somebody will say, I want a mobile phone with a good proper size. The third person will say, I want a mobile phone which is light in weight. So that there are various requirements of the customer. Now, these requirements will be there for any product. I am not saying only for the mobile phone as such. Now you are sitting in this conference hall. So there will be some expectations about the speaker, about the seating arrangement, about the temperature. So everybody will have different expectations. Now these expectations we will have to meet, and then that is the traditional quality what we are speaking about. This is how we measure the quality. You make a call on the mobile phone, on internet, and then you get some rating that how was the quality of the call. And then you rate it. Suppose if you have heard properly, there was no disturbance, there was no other noises, you will say that, okay, the quality of the whatever talk that has taken place is 4 star, 5 star. So you actually rate, you say that, okay, the quality was good. Suppose if you are not able to listen anything, you will say that the quality is very bad. So this is how traditionally we talk about the quality. Facets of quality, all of us we know that it is the performance, it is the reliability, it is the conformance, it is the aesthetics. So like that, there are various facets of quality. This is the traditional thing what we talk about. When we come to sustainability, quality I have already explained. When we come to sustainability in quality is a traditional quality plus something more. And that something more, you have to take care of the environment, you have to take care of the natural resources, you have to also take care of the society at large. Then it is the real quality. The real quality takes care of the conformance quality as well as it takes care of the issues that are there, issues that are taken care for the society and for the environment as such. These are the 7 principles of sustainability. That is the continuous improvement, customer focus, leadership, innovation, adaptation, transparency, social responsibility. I talked about the social responsibility. Another example of social responsibility could be that there is a builder, there is a developer, he is developing a building. Now, while he is developing a building and the people who have paid for booking a flat in that particular building, both of them are happy because somebody is getting a flat and he is getting the money for making the flats. But the people who are around that particular construction site, who has to take care of them? They will be every day facing the problem of dust and noise. Now, when that is taken care, and it has to be taken care because the society at large should not get punished because two people are doing the business with each other. So that is the sustainability in quality. The customer focus, as you know, for example, in many of the industries, you also must be doing it, that there is a heat treatment shop. In few years back, the traditional methods of heat treatment and in the quenching furnaces were different. There were quenching furnaces having the cyanide bath. The hot components, after raising it to a particular temperature, were dipped in that particular bath for getting the required hardness. But the medium, that media is dangerous. So that's why later on the government regulations had come and that particular cyanide bath was eliminated, removed. However, in Tata Group, having understood this particular thing, those were removed years back. So, Tatas were always ahead of the regulation. When the BS1, BS2, BS3 regulations had come, it had come, CMVR regulations had come somewhere around 1998. But I remember we started our work in 1990. And we were totally prepared to launch, to put the vehicle, and the first CMVR vehicle was put on the road even before the CMVR regulations had come. When the BS2 regulations had come, the BS3 vehicles were on the road. When the BS3 had come, BS4 were on the road. So one step ahead. And that is called the sustainability in quality, that you are producing a product, the product is good, the product has got quality, but we have to also take care of the society at large, we have to take care of the environment. For example, we, while working in the industry, we are using energy. Now, when we are using the power and the energy, it comes from the fossil fuels. The thermal power station, they are using coal, they are polluting the atmosphere. So, somebody is producing the energy, somebody is consuming it, but the atmosphere, the environment is getting spoiled. That has to be avoided. The basic principle behind the sustainability in quality is that you have to avoid that. How can we avoid? So, make use of solar energy, make use of wind energy. So, these alternate energy sources are there. So, make use of that and carry out the work. In Tata Motors, by 2028, we will not be depending on the fossil fuels. The entire Tata Motor plants will be using the power from solar as well as from the windshield. So, this is how the energy saving will be done. Once the energy saving is done, the ill effects because of the burning of the coal and burning of the fuels will get avoided. This is a sustainability quality management system. This management system says that by considering these factors, we have to improve the overall performance without affecting the society at large. These are the common sustainability challenges, that inefficient process, it is not energy efficient, and we will have to overcome these challenges by proper planning and acting upon those planning. Now, what supports this sustainable development? These are the four factors, that is proactive leadership, circular economy principles, ethical sourcing, and life cycle quality management. Proactive leadership, as many speakers have already spoken, that the demonstration has to be from the leader. He has to be a role model. He has to demonstrate that what is required, because unless and until he does it first, the others may not follow. So that is why leadership is very, very important. I will share one more example with you very shortly. It was sometimes in 1990 or 91, I don't exactly remember the date. And that time, Mr. J.R.D.